Hello everyone, my name is Arab. I'm from Bangalore. I'm studying in grade 9 and I study in a school called NHVPS. So, the reason why I got interested in robotics is because of a science exhibition that was held in our school in the beginning of the year. In that science exhibition, our topic was about solar energy. So, we were supposed to make around four models regarding to solar energy, and we were planning to make a solar car, but it was not possible. But still, we tried to make a solar aeroplane. So, while making all of these projects, I experienced a lot of excitement, and I felt it was very fun. So that is the main reason for me to join this class. And after knowing about Plato Labs and the fact that they also teach us coding in C++, I was very eager to join and know how it is to build a robot and how it feels to control a robot. So now getting back to myself, some of my hobbies are solving the Rubik's Cube, painting, and I love science and math. And I also like building things. That is also one of the reasons for joining the class. So, coming back to the robot, this is the robot which I'm going to talk about today. It's called the obstacle avoiding robot. So, as you can see, the robot, it seems to be very complex and it has a lot of wires connected to the main Arduino board. The Arduino board is connected to the computer. So, if we think about the robot, it's the obstacle avoiding robot. So, a few real life examples are like autonomous cars, which are in the making. Tesla has a few of them, and if you know, there are a few robots that can clean the house. They have these sensors in them, which can sense if there's any obstacle in the front and what they should do accordingly. And also drones and irrigators in modern irrigators in farmlands and which are used in agriculture. So now I'm going to run the program once and you can see how the robot works. One minute before that, I'm just going to connect the battery. As you can see, this is a 9-volt battery. I'm just going to connect it to the Arduino board. As you can see, the robot is working. I've connected the 9-volt battery. Now it's moving forward because there's no obstacle in the front. If I leave it, it will just go forward. Now if I, one minute, it's just too difficult to understand. So now, if I leave it and then my hand is obstacle, it moves to the opposite direction where the like obstacle is. So now I'm going to take this. I'm going to place this here. Oh wait, it's not going to sense that. So if you can see, it's avoiding the obstacle. As you saw, it just avoided the obstacle. And now, that was the first condition. If it senses if the right side, it's going to move left. That just means it's going to move the opposite direction of wherever the obstacle is being sensed. It's moving the opposite direction. Now, if I keep my hand in front of the left part of the sensor, it's going to move right side. Okay. So now it just did the opposite of where opposite of the same thing. So now you can see that the last condition is the robot should stop if it is sensing in the both. It should go backward if it's sensing in the both of the IR sensors. As you can see, it's going backward. So that was the output of the robot. The only way to stop the program is by disconnecting the battery or pulling out the cable. So I just disconnected the battery for now. Okay, so as all of you saw, the robot was doing as directed according to an obstacle avoiding robot. Whenever it's sensed in this sensor, it is going in the opposite direction. That is, if it sensed in the right side, it moved left. If it sensed in the left side, it moved right. And if it sensed in both of the sensors, it just moved backward. So as you can see, there's still a little power present in the motor driver, so it's just working. Otherwise, I'll remove the battery. So now coming back to the components. So these two are the main components for now. They are the IR sensors, stands for infrared sensor. So here, this bulb over here is going to produce some light which is not visible to the eye because it's too powerful, and this is a sensor which is going to detect it. So this is called infrared light, which is produced by this, and this is going to sense that infrared, right? That's how it is going to sense the obstacle in the front. As you can see, there's a green light produced when anything is detected. See, and then the same here, same thing. Now going back to where it is connected to the breadboard. The breadboard is connected to the main part, which is you can call the motherboard, or it is its name is the Arduino board. So the Arduino board is the most important part of the robot. It is connected to the desktop. So this is the place where everything is connected. See, the motor driver is connected to the Arduino board. The IR sensors are connected to the Arduino board, but they're not directly connected, but they're indirectly connected. Like, see, the breadboard, this orange wire is connected to this part of the Arduino board. So the IR sensors are connected to the breadboard and the Arduino board. So the breadboard is connected to the Arduino board. Breadboard is like an extension. If there's no space enough in the Arduino board, you can use a breadboard. For example, see, the IR sensor has three pins, which is out, that is one of the analog pins over here. Both of them are vacated. And next is GND, which is a negative pin. Both the GNDs are vacated. There are only three GNDs, and all the three GNDs are vacated. So I just connected to the Arduino, to the breadboard. So I connected this to the breadboard, and even that to the breadboard, the GNDs. And the last one is the VCC, which is a 5-volt pin. If you can see, 5-volt pin. Actually, I'm very sorry, I've not connected the GND to the breadboard, but I've connected to the 5-volt to the breadboard. So next is the motor driver, which connects like wired parts of the wired components. These are like pinned parts. If you can see the pins, so I'll just put it back. Okay. So okay, so the motors, that is the BO motor, which is connected to the wheel, is screwed here to the main part, the chassis, and here also. So the wires of the BO motor are connected to the motor driver, if you can see, and this is the battery connector. It is also connected to the motor driver. So the motor driver is connected to the Arduino board and the breadboard. So that is about the components. So that's it about the components. The main components, the electrical components, are connected to the chassis board by these double-sided tapes, and the turning wheel uses the ball bearings to turn around, and it's also connected to the chassis board using the screws. So now I'm going to talk about the software that I used to build this robot. So this is the software that I've used to develop my code. It is called the Arduino IDE. IDE stands for Integrated Development Environment. So Arduino IDE is a software app that was developed by David Mellis, and now it uses the programming language C++. It contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and a series of menus. The two main functions, as you can see, is loop and void. Sorry, it is loop and setup. As you can see, void setup and void loop. So these are the two main functions used. Now I'm going to go back to the code. So as you can see, this is the code of the robot. So we're gonna come from the beginning. This is int lir is equal to 4. That is, lir is nothing but left IR sensor. So IR sensor is this. Left IR sensor is this. So next is RIR, that is the right IR sensor. So 4 and 2 are basically the analog pins, as you can see, A2 and A4. Now next is LM1, that is the left motor 1 and left motor 2, right motor 1 and right motor 2. As you can see, the motor driver has 4 pins over here and it is connected to the Arduino board. So as you can see, 9, 10, 11, 12. Here 9, 10, 11, 12. So LM1, LM2, RM1, RM2. Then comes the first function, that is a void setup. Pin mode LIR input. This is just stating that left IR sensor is an input device. For example, see, the IR sensor has an IR value, that is the sensing value. So that is taken as the input. Same for the right IR sensor. LM1 is an output, as a motor is an output. And same for the right motor. That was, and then coming back to the next function, that is a void loop. Here I've created three more variables actually. So actually you have to avoid this. So there are two variables here, which are IR value 1, IR value 2. That is nothing but IR value 1 is nothing but analog read LIR. So this is another name for the left IR sensor, and IR value 2 is the another name for right IR sensor. So this is serial.print for both the values. For is going to come in the serial monitor. So the value for both the IR sense is going to come in the serial monitor. So that is nothing but serial.print. Next are all these if conditions. So these are where the main part come. For example, if the right IR sensor is sensing, it has to go left. So here is the code for going front. If both the IR sensors are not sensing anything, they're going to go front. And if the IR value 1, that is the left IR sensor, is sensing something and the right IR sensor is not, it's going to move towards the right. So low, high, that is digital right RM1. Low is on, high is, low is off, high is on. So here this is the code. If one of them is on, see, for going front, both of them should go front. So both of them should be on and one of them should be off. Then for going left, the so for going left, one of the right motors should be on and one of the left motors should be on. So motor is divided into two parts. That's why it's written right motor 1 and right motor 2. Actually, you can see only two motors. That's why it's a bit confusing that there's only one. There are only two motors, right motor and left motor. So there are 4 pins, which is taken as right motor 1 and right motor 2 and left motor 1, left motor 2. Mainly there are only two motors. So coming back to the condition, second condition, if the left IR sensor, that is the IR value 1, is detecting something and the right IR sensor is not, it's going to go left. This is the code for going left. RM1 should be on, RM2 should be off. LM1 should be off and LM2 should be on. Next is the third condition, which is for going right. For going left. If the left IR sensor is not detecting anything and the right IR sensor is detecting something, it's going to go left. So this code is for going left. And then the last code, which is for going back. If both the IR sensors are sensing something, they're going to go back. Okay, so this is the main part, as you saw the code, and this is the robot. So let's summarize. Now the robot is made using the software Arduino IDE and many various components. The most important component is the Arduino board. All the other electrical components are connected to the Arduino board directly or indirectly. For example, the IR sensor are connected to the breadboard. The breadboard is connected to the Arduino board, and the motor driver is connected to the Arduino board, but the motors are connected to the motor driver. So the motor are also connected to the Arduino board. So now, as we know that all the components are directly or indirectly connected to the Arduino board. So the Arduino board is connected through this cable to the desktop, which interprets the code. So now the code is going to be transferred from the electrical cable to the Arduino board. The Arduino board is going to store the data, and all the components connected is going to follow it. So this is the working of the um, obstacle avoiding robot, and there are many daily uses like the cleaner robot or the autonomous vehicles. In the future, this will be a great use. And for example, if a blind person is using a walker stick, it might detect something and warn him or something like that. So this might be a great use in the future. So that's it about this robot. uh, I hope you learned everything. Thank you.